and welcome to the third lecture of this series. So in this lecture, we'll be starting with the basic concepts of it. So in the last two sessions, we've discussed about how to write a chemical formula, and how we understand what ions are, what cation are, what anions are, the basic rules about them. And then we discussed about, how to write chemical formula from name to formula, from formula to name. And this in the class today, in the lecture today, we'll be discussing about the basic concepts, some very basic concepts which we have. Let's start with the first one, matter. I'm starting with the very basic one. So what's matter actually? Matter is something which has substance which have mass, substances which have mass, and occupies volume. So anything which has mass and occupy volume, the substance which has mass and occupies volume is called as matter and occupies space. That means anything which has some mass and occupies some space, like it would be gas, solid, liquid, whatever it is, but it should have some mass and should occupy some space. Example, air, water, chair, all this, like deodorants, all these things, and all these things are basically matter. You, me, laptop, camera, phone, all of these are matter, right? We know that. Now, what are matter made up of? Matter is made up of particles. Now, when I say particle, what exactly do I mean by that? When I say particle, I mean atoms. When I say particle, I can also mean molecule. It depends. Depends on what? I'll tell you in some time. And when I say particle, I also mean ions. So broadly, matter is made up of either atoms, molecules, or ions. Now you must be wondering, is it not everything is made up of atom? Then why are you saying molecules and ions also? Yes, they are made up of atoms essentially, but their basic particles differ every time. Let me explain. Like for example, water molecule. What is it made up of? So you may say that it is made up of hydrogen oxygen atom. Yes, you are correct. But if I talk about a glass of water, what is the basic particle? The basic particle is not going to be hydrogen oxygen. The basic particle is going to be H2O. So water, a glass of water is made up of molecules. It's not made up of atoms. I mean, that would be correct technically. It is made up of atoms, but the basic particle here is substance. The basic particle here is molecules. When I say NaCl, suppose I have a crystal of salt, common salt, a crystal of it, suppose. What is it made up of? So you may say it's made up of sodium and chlorine atoms, but you are right, but not 100%, because it's actually made up of sodium plus and Cl minus ions. So they're made up of ions essentially. Because if you break it, the smallest particle you'll get is not sodium, it's Na plus. That's why it is made up of ions. And suppose if a piece of iron bar with me, see, a piece of iron bar, and these are the atoms we have, right? These are the atoms we have. So they're basically made up of atoms. If you break and get the smallest particle, that would be an atom. That's why I said matter is made up of atoms sometimes made up of molecules, and sometimes made up of ions. Now, moving on. Matter can also be classified into two types depending on how pure it is. So matter has another two classification that we must know. One classification, it's called as mixture. And the other classification, it is called as pure substance. Pure substance. So here we had, see, as you can see, which occupies mass in a space. Matter is made up of particles, as you can see, and these are the examples, right? So a substance which has mass and occupies space is matter. Matter is made up of atoms, molecules, ions. Now, matter can be of two types: pure substance, mixture. Now, this can also be of two types. Pure substance basically means they're basically made up of made up of two or more same or different atoms, right, or particles in a fixed ratio, in a definite ratio. I'll talk about it in some time. In a definite ratio. But what are mixtures? They are basically, the components are mixed in two or more substances present in any ratio. Two or more substance present in any ratio. In mixture, we don't have any ratio, in fixed ratio, in any ratio. The ratio can be anything, right? For example, when I say sugar solution, that's a mixture. See, solution, that's a mixture. Now, if you are, you're someone who likes sweet a lot, you're a sweet tooth, then what will happen? You will add a lot of sugar in it, right? So that in that case, you'll add a lot of sugar. That makes it, that makes it, see, you may add more sugar. I don't like sugar. I will not add that much of sugar, right? That means your sugar solution and my sugar solution may not have the same taste. Your sugar solution may be sweet, my sugar solution may be not that sweet. That's why I said that it can be in any ratio. You may put 2 spoons of sugar and 1 milliliter or 10 milliliters of water. I may take 1 liter of water in 2 tablespoons of sugar. So the ratio changes every time, right? So the ratio changes. The ratio changes. Whereas in the case of pure substance, the formula is fixed. Like for example, water. No matter I have 1 drop of water or 10 liters of water, the formula of water is always the same, H2O. That's why it is called as pure substance. Moving on. Let me discuss the type of pure substance and then types of mixture. Let's begin with type of mixture here. So how many types of mixtures are there? I'm just running it through the concepts so that you can know what they are. Mixtures are of two types, homogeneous and heterogeneous. Homogeneous and heterogeneous. Heterogeneous. What is homogeneous mixture? It's a mixture in which it has same composition throughout. Like for example, sugar solution. When you add sugar in water, after it is thoroughly mixed, we can never understand where the sugar went. What's an heterogeneous mixture? It's a mixture in which the compositions are different. It has different composition, right? The components can be seen actually. It has uniform composition, it has non-uniform composition. I'll just give an example so that you can understand it properly. See, homogeneous mixture, the example can be sugar in water, sugar solution, or air that you breathe. Now, see, there's air around me, right? Can you see where is oxygen, where is nitrogen, where is helium? We don't know. It's thoroughly mixed. That is what makes it an homogeneous mixture. An heterogeneous mixture is basically oil in water, sand in water. See, sand in water. If I mix sand in water, sand will settle down. Water will be separate. It will be different layers, right? So they have basically different layers. So they cannot be, they can be identified from, distance also. Oil in water. There can be many more examples of such kind. Okay. Next one, types of pure substance. So pure substance, as I told you, they are made up of substance in fixed ratio. It could be made up of two or more different substances of same it could be made up of two or more, or it can also be made up of one. So let's see how. So pure substances can be of two types. First type is called as element. So it's made up of same type of atoms, same kind of atoms. So elements are the substances which are made up of same type of atoms. Whereas pure compounds are the ones which is made up of two or more different kind of atoms. It's made up of two or more different types of atoms. Two or more different types of atoms. Example, sodium. See, it's made up of just sodium atoms. So it's an element. Oxygen. Now you may say oxygen has 2 atoms, then how are you saying it's an element? It is an element because it's made up of same atom, C, O, O, same atom. Sulfur, S8, that's also an element. It has a different name, I'll tell you what that name is, but essentially it's an element. I cannot deny that. It's an element. Like for example, oxygen, chlorine, or sulfur, they all are elements. Okay. Compounds, they have a different name, of course. They're called as molecules. I'll talk about that also, but they're essentially an element as well. Compound can be water. See, the ratio is 2:1 and it's fixed. Whether we have 20 liters of water or 2000 gallons, it doesn't really matter, or a 1 drop. The formula is H2O. The formula does not change, right? Fixed formula. H2SO4, it's a compound. Okay. I hope you're clear on what element and compound is. Now the thing is, if that's an element and this is the compound, what exactly is molecules? These are like common terms that people usually get confused with. So molecules are the ones which is made up of, I mean, they are the ones which is, they are a group of atoms. They are group of atoms. And when I say group of atoms, see, when I say group of atoms, it could be anything. If I say they are a group of atoms, it could be anything. Meaning the group can be of same atoms also. The group could be of same atoms. The group could also be of different atoms. See, the group can be of same atom. It can be also made up of different atoms. If the group is of same atom, like for example, P4, S8, O2, then they are called as element of molecules of element. They are also called as molecules. But if they are different elements, then they are called as compounds. You see, essentially, essentially they're the same. I may also call it as element and a compound. So what is molecule? Everything is molecule except sodium, right? Everything is a molecule. It's just that some are compounds and some are elements. What I'm trying to say is, if I tell you that ozone, HNO3, P4, what is ozone? It's basically made up of only oxygens, right? So it's an element. But more correctly, it is going to be a molecule. Why? Because it's made up of, why is it a molecule? Because it is a group of atoms made up of same atoms. HNO3 is a compound, right? Because it's made up of 2 or more different atoms. But it is also a molecule because essentially it's a group. P4, is it an element? Yes, but majorly it's a molecule. This is the conceptual clarity that you must have when these terms are considered. Now, let's do some questions and then we'll wrap up the session. So questions are, identify the following as homogeneous, heterogeneous, compound, molecule, element. You need to tell me what they are. First, glucose, C6H12O6. Glucose water, glucose solution. Third, milk. Fourth, lactose. Okay, solve it. So you can pause the video now and do these questions. So please pause the video and attempt these questions. Okay, let's solve it now. So glucose, is it made up of 2 or more atoms? Yes, it's made up of 2 or more atoms, right? So it would be, is it a homogeneous mixture? Of course, no. Can it be a heterogeneous mixture? It's not a mixture. Is it a compound? Yes, it's a compound. Is it also a molecule? Yes, it's a compound as well as a molecule. Glucose solution, it's a solution now. So you might have, when you come out from school and all of it's a very sunny day and then you say, "Mom, I'm very thirsty," and then your mom basically gives you some white color powder and mix it in water, and you drink it and you feel energetic. What is that actually? That's glucose solution. So when she mixes it, do you see glucose anywhere? Particles of glucose anywhere? No. It's a mixture, homogeneous mixture. See, we don't understand where the glucose went, and it has same taste throughout. Of course, if you have purchased a good quality one, it's a homogeneous mixture. Okay, milk, that's also a mixture, right? Heterogeneous. Why heterogeneous? Because milk has, if you look at a very minute level, it has heterogeneous nature because the fat is quite visible. Lactose, on the other hand, which is present in milk, is a molecule and a compound, of course, because it's made up of, basically it's a compound made up of carbon, hydrogen, and oxygen. What's the formula? We don't really have to know it. It's an O's compound, as in it's a sugar. So that's how we can understand. So I hope this session was useful, where we learned about, basically we learned about what matter is, what's matter made up of. There's one more thing I should tell you, that matter is made up of particles, and these particles are very small in size. Particle of matter is very small in size. And how small it is? Size of particles are typically in the range of 1 angstrom, meaning 10 to the power minus 10 meters. That is how big the particles can get, right? So 10 to the power minus 10 meters is the size of particles we have. Okay. Then we discussed about what's matter's division. What is matter, what's pure substance, what mixture is, homogeneous, heterogeneous. Then we discussed about element, compound. Something is made up of same kind of atoms, it's an element. Different kind of atoms, compound. Then I discussed what molecule is, because that's often confused term for students. Then we discussed some questions, and that's what we've covered. So this is the end of this lecture. Next lecture we'll continue and see the basic concepts of some different laws that the scientists gave, and all these things. So let's meet in the next lecture. That's it for now. Thank you so much.